The most potent training signal for intelligent systems might just be the data itself, without human labels. This is the core premise of self-supervised learning. Self-supervised learning, or SSL, isn't unsupervised learning. It's a clever technique that generates its own supervision signals from the inherent structure within vast unlabeled datasets. Imagine extracting knowledge from the data by the data, for the data. The mechanism often revolves around pretext tasks. Consider masked language modeling, where a model predicts intentionally hidden words within a sentence. This forces it to learn contextual relationships, or in computer vision, contrastive learning approaches like SimCLR or MoCo. They create multiple augmented views of an image, then train the model to pull representations of these views closer, while pushing away representations of other unrelated images. The label is simply whether two representations originated from the same source. This methodology has birthed foundation models like BERT. Pretrained on gigantic corpora of unlabeled text, BERT learns deep linguistic patterns. It then requires only a fraction of labeled data for fine-tuning, excelling in tasks from sentiment analysis to question answering. In medical imaging, self-supervised pretraining on millions of unlabeled X-rays can yield robust feature extractors, which then generalize exceptionally well to specific label-scarce tasks like identifying subtle disease markers. Compared to traditional supervised learning, SSL dramatically reduces the dependency on expensive, time-consuming human annotation. It bypasses the label bottleneck. Unlike purely unsupervised methods that often produce less transferable features, SSL generates rich, task-agnostic representations, foundational for diverse downstream applications. Its efficiency meets efficacy. A fascinating yet often overlooked implication is the rise of multimodal self-supervision. Models are now learning joint representations across inherently different data types, like images and text, using self-supervision. Think Clip, which learns to associate text captions with images without explicit labels, by simply predicting which text-image pairs belong together. This approach unlocks entirely new levels of semantic understanding, bridging modalities purely through intrinsic data relationships. Ultimately, self-supervised learning isn't merely a sophisticated pretraining step. It fundamentally redefines how we extract intelligence from information. It transforms raw data from a passive resource into an active teacher, democratizing access to powerful AI by circumventing the prohibitive cost and inherent biases of human annotation. It's an architectural shift towards more autonomous, data-efficient AI development.